Yes, Paramita, you can start. Sir, can you come in the video mode at the starting of the program?
Sure.
And if you please now stop the screen sharing, then after
Okay.
this,
Sure. Just 1 second.
okay, Paramita.
A very good morning to all present here. So today we are at day 2 of the AICTE AQIS sponsored STTP phase 2. So we are at the beginning of the technical session 3. So in this particular session, we have Dr. Chinmay Chakraborty as a resource person with us. So we are very much pleased to have Dr. Chinmay Chakraborty with us as the resource person. So may I take the pleasure to introduce our resource person to all the participants and others present in the program. Dr. Chinmay Chakraborty is an assistant professor in the Electronics and Communication Engineering, Birla Institute of Technology, Mesra, India. He worked at the Faculty of Science and Technology, ICFI University, Agartala, Tripura, India as a senior lecturer. He worked as a research consultant in the Cool India project at Industrial Engineering and Management, IIT Kharagpur. He worked as a project coordinator of the Telecommunication Convergence Switch project under the Indo-US Joint Initiative. He also worked as a network engineer in system administration as MISPL India. His main research interests including the Internet of Medical Things, wireless body sensor networks, wireless networks, telemedicine, M-Health or E-Health, and medical imaging. Dr. Chakraborty has published more than 100 papers at reputed international journals, conferences, book chapters, and books. He is an editorial board member in the different journals and conferences. He is serving as a guest editor of Future Internet Journal of MDPI, Internet Technology Letters of Wiley, Annals of Telecommunications of Springer, International Journal of System Assurance Engineering and Management Springer, Environment Development and Sustainability Springer, Business and Society Review, Wiley, and lead guest editor of IEEE JBHI, Journal of Health and Medical Communications, IGI, Multimedia Tools and Applications, Tech Science CMC Springer, and also Associate Editor of International Journal of End User Computing and Development, Journal of Science and Engineering, International Journal of Strategic Engineering, and has conducted a session of SOCTA 19, ICICC 2019, Springer CIS 2020, SOCTA 20, SOCPAR 2020, and also a reviewer of international journals, including IEEE Access, IEEE Sensors, IEEE Internet of Things, Elsevier, Springer, Taylor and Francis, IET, and many more. Dr. Chakraborty is co-editor of several books on smart IoT, healthcare technology, and sensor data analytics with Elsevier, CRC Press, IET, Penn, Stanford, and Springer. He has served as a publicity chair member on renowned international conferences, including IEEE HealthCom, IEEE SPDLT. Dr. Chakraborty is a member of Internet Society, Machine Intelligence Research Lab, and Institute for Engineering Research and Publication. He received a Best Session Runner-Up Award, Young Research Excellence Award, Global Peer Review Award, Young Faculty Award, and Outstanding Researcher Award. He was the speaker for the AICTE DST sponsored FDP and CEP short-term courses. So, sir, on behalf of Department of Applied Electronics and Instrumentation Engineering, Guru Nanak Institute of Technology, we welcome you in our STTP program as a resource person. We are very much honored to have you with us as the resource person. We think that our participants will be greatly benefited by the informations which you will be sharing during your session. Sir, we welcome you once again in our session. Now, I would request our coordinator, ma'am, Mrs. Bapita Roy, to felicitate our honorable speaker with a virtual flower bouquet. Ma'am, please give me 1 minute time to share my screen.
Okay. Welcome, sir, to STTP Phase 2, AICTE sponsored STTP. And this is the token of appreciation and respect from the Department of Applied Electronics and Instrumentation Engineering, JNIT. Thank you, sir. Now you can share your screen and you can start your presentation.
And thank you very much. And this is the well presented, and both of you, and Professor Mukherjee and Professor Roy. I am very much thankful to you. And this is the one of the good opportunity for me to interact with you and means your participants. And I believe that is all of you know the basics and the real scenario of today's life. So that's why now this is the time for interacting. I believe this is the one of the interactive session, and we want to recapitulate the real scenario with the yesterday features and your upcoming feature based on the present scenario. Can I start?
Yes, sir. Sir, can you go to the slideshow mode?
Okay.
Then it will be full screen. Yes, sir. Okay. Okay, sir.
Okay. So thank you very much once again. And today we'll discuss, for the titles, the green technological revolutions for smart society using Internet of Things. One chat is coming. Okay. So this is first in this title. Basically, we want to discuss what do we mean by green, what do we mean by technological revolution at the present moment, and specifically what the definition of the smartness, smarter device, smarter technology, smarter algorithm, and smarter device, and how to develop the society in a smart way in the help of the IoT. Without IoT, it is difficult. It's the Internet of Things. So things means this is the objects, and in our society having means large number of objects, and how to interact and how to accumulate the data. So that's why we'll discuss one by one. So before going to discuss, once again. With a self-portrayal kind of the recent books related to this IoT related specifically. For one is the communication systems, like how to handle the heterogeneous data over the diverse networks. So That's why this is the first book, second the smart healthcare, third one, and most of the books published in Springer, and almost means more number of books currently is going on. He will be coming soon. So my intention is that objective is that to focus how to develop our society in the help of Internet of Things. And next, this is I'm the editor of several journals. I have few already mentioned. So in IEEE and the others, Springer and Elsevier also, he will be coming soon. So all special issues, if you search in my website, you will see based on the smart health, smart industry, and smart society related, specifically for IoT. The contents. In the first stage, we will discuss for Green IoT and smart IoT, smart societies, the basics and introduction. I believe you know the basics, but we want to recapitulate once again. If you know the basics, then definitely you can jump to the higher level. And then societal IoT application. Okay, IoT application is two parts. One is I have mentioned the industry 4.0 and health 4.0 and Tele robotics. Okay, so that's why this is the robotic of things. So later I'm coming to this point. The first three part, one is the data acquisition, another one is data processing, and third one is data manipulation and data gathering. Means your different clustering techniques and others, how to use. So that's why we have discussed mainly in the three parts. An application is industry 4.0 and health 4.0. And here I will mainly going to focus on health care systems, how to develop the healthcare, how to develop the remote healthcare, how to develop the rural healthcare, how to communicate in easy way, means one village to another village via one city. And another thing is there, this is the decision-making system is required when we are transferring, when we are acquiring, and when we are manipulating, when we are scheduling and routing. Each and every stage you need to set up some decision-making unit in the help of artificial intelligence. Or if you would like to take some decision, but if you would like to optimize the data, so different kind of optimization techniques are there. Yours optimal scheduler design, optimal routing path design. So that's why each and every stage is decision-making system is highly required. But our intention is that we need to develop some adaptive techniques, our own techniques. We need to develop. Okay. And the last part, two case study, means medical imaging related. This is the rural healthcare and how to map with the health 4.0. So we'll discuss. One is chronic wound related. Wound means this is the one of the ulcer. Mostly the aged people facing this kind of problem. Another one is the epileptical disease problem in the help of how to resolve it using the machine learning systems. And see the present time, we know we are facing means some COVID related news and in the practical life. So that's why somehow the impact of COVID-19 pandemic, this elaborates on the contemporary issues, social, environmental, economic impact, and different policies concerning the COVID-19. So one thing that is, it is understood that the absolute impact of this perpetuating pandemic is yet to be fully evaluated, but it has opened a new scheme of integrated understanding, incorporating the vitality of conservation of biodiversity with traditional and state-of-the-art medicine, diagnostic, and treatment technology. So this is the session wise. So first, more briefly, this is the discussion. The brief points like IoT, smart society, and security, and telemedicine, mHealth, eHealth, telesurgery, and IoT in healthcare, and different communication aspects, and how to play the major role in basically for the sensor data analytics or the sensors like WBAN and wireless body area networks. You know that is we are capturing means patient-centric data, use the multiple number of sources, multiple number of objects and devices, and means your systems also. So see, in the first session, is the Green IoT and smart society basics. So before going to the depth of the analysis, the depth of this today's presentation, one thing is that we need to remember that is a Gardner chart. We have to follow this chart. Because of that, this is purely, and this chart is for this is the technological growth. So recent technological growth is the hyper chart. In here, see, means time versus expectation. And this is 2000 means your 19 chart. One error is coming in the screen. So here the multiple number of technologies, and time to time they have been playing a major and vital role. And this is a 2018 chart. And here first starting the smart dust, after that is artificial intelligence, and is computing, fog computing, and cloud computing, you know, as well as artificial intelligence based technology day by day means suppressing the traditional methods. And for the next year, 2019, same case, but in top one, the 5G technology, and we will discuss some brief related to 5G technology, and as well as means autonomous driving, next generation memory, 3D sensing cameras, and another one the biochips, you know, or biochips using the biomemes. That's why this is the another chart in the last year. And 2020 vision, it says that is a responsible artificial intelligence, adaptive techniques, adaptive machine learning techniques, adaptive algorithm. So somehow that is adaptiveness is required for processing the data, and you have to take the proper decisions, and as well as some security aspects. This is highly required for processing any kind of data from one side to the another side. And ontologies and graphs. Ontologies means your disease mapping. Okay. And for smart society related, these are the technologies, and this is varies with the time versus expectation also. Here, artificial intelligence. Next, how to improve the circular economy, and different city-based operation centers, means manipulation center, data manipulation centers, or information kiosks. And again in the 5G, and this is the short range communication techniques. And currently means in the India deployment means 28 gigahertz, but targeting the 60 gigahertz. So faster data communication is required. And smart city based framework. Next, some connected home IoT platform, connected devices, how to connect the multiple means electronic gadgets, in their home. And next, vehicle to vehicle smart transportation systems, robotic systems, means this is target is that how to develop some automation kind of things. See, this is the general. So one error is coming in the screen, I don't know. Okay. According to McKinsey, sensor and actuators embedded in the physical objects are linked through wired and wireless networks. That means this is the heterogeneous networks. Okay, in the wireless side, the structure is one, wired side, the structure is another. And sharing first. No. Any problem? So IoT, this is the complex architecture. Complex architecture means this is IoT is not a particular device. IoT means this is a set of devices, set of components that interact with each other to enable the different solutions. So first see the roadmap. In 1999, IoT first coined by the Kevin Aspen, and this is promoted the RFID technology first tag. One is cow that is having a one tag. So based on this information, and they can process the data. And then means after 10 years later, IoT didn't accelerate. So after 1 year, that is the Gartner introduced some hyper cycle for emerging technologies of IoT. 2013 and 14 is the mass scenario. The real scenario is reached and covered in the came into the picture. But in 2018 onwards, so 19 and 20, in 5G networks enhances the overall development with the 4.0 in the help of the augmented reality and virtual reality, as well as you can say this the mixed reality for the societies. Namaskar in the help of machine learning. So that's not machine, you can use the deep learning also later. Means I'm coming to this point. But in 2020 and beyond 2020, that's a 28 billion sensors will be in use for the economic growth for $1.7 trillion. So the green IoT. So smart world, before going to the discuss for the green IoT, what do you mean the green? Green means that is several objects and several devices can automatically and intelligently collaborating each other. So automatically and intelligently, two is the two vital terms. And how to interact with each other, how to collaborating with each other. So all devices in the smart world are supposed to be equipped with that, means your additional sensory and communication add-ons. Therefore, there is a sense of the real world and interact with the other. And you know, for the cyber physical system in 5G, this says that is how to interact with the physical world, the virtual world. So physical world to the physical to virtual world and virtual world to physical world, virtually they are interacting. Okay. So that's why in the help of the cyber physical systems. Oh. And green IoT. Green IoT, this is focuses mainly the energy and the efficiency of the IoT applications, IoT principles. So our intention is that how to improve the efficiency, how to improve the effectiveness during processing of the data, during accumulate the data, acquisition of the data. And several applications are there based on the green IoT, like a green smart cities, smart healthcare, industrial automation, smart homes, smart grid, many things are there. But how to enable the green IoT? These are the technological point of view we need to think, we need to explore. First one, this is the green radio frequency networks. Second, green wireless sensor networks. Third, this is the green cloud computing and green machine to machine communication systems and green data centers. And you know, means beyond 2020, this is the time for the data analytics. Okay. And 6 elements of Green IoT. This is, first one, the identification. Proper data identification is required among the devices, among the sensors, sensor to the coordinator, if you consider any kind of WSN networks, and proper sensing is required. Okay. And communication technologies means sensor to coordinator. That means the short range communication technology is required. Proper computation, you have to measure some computational complexity. If you measure the computational time, and next your applications and semantic also. So these are the 6 major elements and associated with the Green IoT. So using these parameters, using these kind of parameters, with the help of this kind of parameters, you can improve the efficiency of the system. By efficiency of the model. Model means the IoT-based model. So the concept, and so that's why for societal point of view, the green society or green IoT. So basically, you can say this is the Internet of everything. Internet of things means object. When we are considering for society, when we are discussing for society, you can say this is the Internet of everything. So see in this diagram here, means scope versus reach, and here this is the web of things. Web of things means a set of means software architecture style and programming patterns that allow the real world objects. Okay, using the WWW, there's objects and device, people, and world. So machine to machine device, machine to machine communication technologies that allow the both wireless and wired system to interact via means with each means every devices, same type devices. And next to industrial IoT, and the integration of the complex physical machinery with the network, sensor, and software. The handling basically the industrial Internet of Things. Okay, and Internet of Things, that is the physical objects are linked with the wired and wireless network. So I told you before, that means we are playing with the heterogeneous data. We are not handling, we are not considering only for the homogeneous data. Okay, so that's why means this is the physical to means your virtual world interaction. They are having some kind of limitations. So under the 5G research area, I will discuss. So bringing together people, process, data, and objects to make a network connections more relevant and valuable than ever before. So this is known as the Internet of Everything, or Industry 4.0. You know that it includes the all kind of connectivity concept mainly. That is, advanced features are associated with the Industry 4.0, Industry 2.0, Industry 5.0. Same thing. How to first you need to develop with means your various kind of devices, and how to provide the superior means the better flexibility and better usefulness to the users. So this is known as the industrial means technological growth. Basically, this is developed from Industry 4.0 and Smart Society 4.0 and Health 4.0. Anything you can say, and as well as some augmented reality and virtual reality, 3D printing, each and everything is coming soon in the market. Already is there. And this is basically my IEEE 1 transactions, basically an augmented and virtual reality we have discussed related to the spinal imaging perspective. Second, in 2020, 2000 to beyond 2020, here for means Internet of Things based technological platform are mentioned, like a supply chain types like RFID tags, that is mainly used for tackling the routing, interpreting, or the preventions. And vertical market, because of the two type of concept there, one is the vertical, another one is the horizontal concept. So vertical market application is very much highly demandable now. So that's some surveillance and security, healthcare, transport, and food safety, document management, each and everything is covered by the vertical concept. Then ambiguous positioning, and some learning analytics and abacus computing or abacus positioning. This is the one of the interesting domain, and this is mainly the locating people and locating by targeting the objects, by finding the objects. Okay. And after that, that is a physical world wave. Here, the teleoperation, telepresence, and ability to monitor and control the distant object, and how to ensemble the all objects. Those are belongs the near and far uh, locations. Okay, and you know that is in some basic concept like a protocol. Anyhow, we need to follow the protocol. Protocol means, what do you mean by protocol? Protocol means a set of rules that govern by the network. What do you mean by networking? Networking means a set of network-enabled devices interacting with each other via a proper communication media, via a proper wireless media. Sorry, via a proper communication media like a guided media or unguided media. Guided media in three parts, you know, means the coaxial cable, fiber optics, and another one is twisted pair. Okay, and this is the wireless. Wireless means air acting the interface. Okay, the air ABUS and AM interface is there. This is dependent mainly the interface. This is the machine-to-machine interaction and IoT using the Wecham research. Here, just see, you can search in the Google also, and it will be like here each and every dimension clearly is mentioned based on means how many sectors are there, like a building, smart object means your energy, consumer and home, healthcare, industrial, transportation, retail, security, and IT and networks. So that's why this is the main target. This is the smart society, smart world. So that's why in the starting I have mentioned the smart world. Because of that, if you go here, devices, location, and application groups and service sectors are associated with these 8 or 9 sectors. It's the subsectors. Okay. Next, so where are we? This is a very simple question, but I have answer. The learning basically the massive impact of life means business and global economy, and there will be the massive influx of data from the connected devices and raw, unstructured and unpredictable data. Unstructured means here that is a I work means one language like a, probably you know the abstract ASN language and abstract syntax notation. So that's how to structure the data, how to structure the unstructured data. Okay. Next, ACT means need for innovation for sensor technology, setup and intelligent network, superior high performance cloud computing. So supercomputing is required. Supercomputing means based on the cluster computing. Okay. So means anyhow that is in this is the under this act you see means 2 terms. One is the how to improve the efficiency and energy. So you know for your Shannon theorem, which says that your capacity equal to bandwidth of C equal to B of B is C equal to B into log of 1 plus SNR, capacity equal to bandwidth into this is the rest. So capacity over bandwidth, that means this is the eta and this is known as the bandwidth efficiency. So our intention is that how to improve the bandwidth efficiency during the communication systems. Okay. So that's why another one, some efficiency and how to improve the effectiveness by taking the proper decision, by taking the faster decision, by taking the faster communications. So that's why one is the smart means you the need some sort of innovations by innovative technologies under the sensor networks, WSNs. Need to set up the intelligent networks and superior high performance of the cloud computing, fog computing, and edge computing. Okay. Next, this is the general introduction we have given, and step by step we will move to some practical aspects later. And before going to discuss one is the major important one is the important aspect in the security. So small discussion means we can do in here. Because of that, In the previous technology, this is known as the crypto, means your cryptography, you know, means your security. So security, privacy, cryptography, cryptanalysis, then steganography, and up now that is just a fog computing. Okay, and today's live, you can say this is the time of for the blockchain. Okay, so in this case, in security, at having means few parameters like a trust. Trust is required, means among the devices. Those are means sharing the data. Suppose if you would like to sharing, if you would like to share the any kind of data from one mobile to another mobile via a Bluetooth, first you need to share the key. So proper understanding is required before transmitting any kind of data. So that's why you can transmit on the request message. Then after getting the request message from the client by the server, then server generates acknowledgement message to the client. So after getting this green acknowledgement message, then client only able to transfer the data. If receiver sends a red negative acknowledgement NAC, so that's why client is requesting, please resend the request message again. So that's why this is the trustness is required and proper identification is required, privacy, data protection, okay, and safety and security. So these means areas for these sectors is highly required for any kind of means secure data processing over wireless or wired networks. So in this case, for security architecture for the smart society, in our society having different sectors, we some general that each and every sector having multiple number of sensors. We are accumulating the data. We are storing a particular one coordinator. Okay, so that's why sensor with security. So that's why each and every sector need to provide some proper security mechanism. Okay, so that's why, and means some conventional or traditional security algorithm takes more time. So that's why in today's life we are using some blockchain technology. Because of that, each and every stage, one device, one node to another node, another node to another node. So that each and every node having one adaptive algorithms. They are screening the data. They are suppressing the raw data. They are only extracting the original information and process to the upper path. Okay, and after mapping, you know, means your header and trailer, and in between one the payload is there, is the information. So when means data is coming from upper layer to the lower layer, so that's why each and every lower layer header protected by the upper layer. Okay, so this is the different area in information security for technical protection. This is the ISTP. Here some key management system is there, and you know the KDC. Okay, and in the for in general or common definition is that you are sending one plain text, one KDC is there, key distribution center, generating the random data. This is the mixed up this data. So that's the plain text converted to the ciphertext. So at the after means applying the decryption algorithms, this is generates the means of plain text. So that's for protecting the data. Okay. Next, means security issues in the healthcare. So here, health devices deal with the private information. Like this information need to protected has been ruled, modified, and forged. And this is here. See the requirements and challenge. First, you need to design the research issue. What is the major research issues are there? So that's why requirements, challenges, and after that different threat models that you have already familiar with these, some attack surface, different attacks, advisory, risks, and consequences. Okay, so these are the major area involved for during any kind of health data transmission. So IoT security requirement basically need for the confidentiality, integrity, and this is the part of the basic security architecture. And just I have added few things for data freshness. Because of that, and beyond 2020 vision, it says that that means this is the data center. the one term. Because of that, we are discussing the smart society. So data center and data hub. So that's why data freshness is required, and how to avoid, how to screening the raw data. Okay. So another point on repudiation authorization, and fault difference, fault tolerance, and self-healing. And IoT security challenges need for the computational limitations, memory limitation, energy limitations, mobility, scalability, and as well as means your communication media. Communication media means one is the guided media, another one is the guided unguided media. Okay, I told you, means a twisted wire, fiber optic, coaxial cable, and the multiplicity device and dynamic network topologies and multi-protocol architecture. Multi-protocol network, that means we are processing the data, not only the same set of device, not only the same network. So that's why this is the diverse network. Many times I am saying, so that's why somehow we need to improve the quality of the service. Okay. And as well as dynamic security mechanism is required. Dynamic security means, I told you, that is some blockchain concept. That is each and every stage, each and every node need to take means some intelligently some decision, intelligently secured the security decisions, not for traditional. Okay, maybe node 1 to node 2 having one type of security, maybe node 2 to node 3 having a different set of security. So this is known as the adaptiveness is required. Okay, with the low data strength. If data strength is high, that means that is some bandwidth requirement is also high. So you need to screening the means unnecessary or raw data. And blockchain, that is a ability to generate and securely distributed in permanent, which is the faster record in transaction. Healthcare and industry, each and every sector, for smooth transaction related issues, mainly the blockchain performs well, like a transparent, reduced transaction time, is the fastest transaction. And when you go to any hospital, they are taking much time, the server down. No. So that's why our intention is that we need to avoid directly to the server. Any data we need to map with the cloud. So this is better, this is easy to access, and this the storing capacity is also high. So cost effectiveness, security, and irreversible transaction, interoperability is required, internetworking, intermapping, and scalability, and how to improve, how to enhance the storage space, buffer space. Okay. Next, social acceptance and required some standardization. This is the lack of standardization is right now. That means standardization means that is one thing I want to recapitulate. Hope you know, means in the IEEE standardization I am talking about. I mean IEEE 802.1, this is used for the means the high performance LAN. IEEE 802, this is the logical link control. Okay. IEEE 802.3, this is used for the Ethernet. Ethernet, why Ethernet? Because of the Ethernet act as the interface. Why WLAN is become stronger? In the help of only Ethernet. Okay. And .4 technology, IEEE 802.4, that means .4 technology, this is the token bus. .5 technology, this is the token ring. This is the unidirectional, but this is provide the faster response. And next, .6 technology, dual queue, dual bus. .11 technology, IEEE 802.11, that means this is WLAN. In the Wi-Fi, wireless fidelity. And next, to the .15 family, having the multiple number of short range communications like ultra wideband. I mean, it's a .15.3a. Okay, it provides 3.1 to 10.6 gigahertz range. And then .15.4, this is the Zigbee. Okay, and .6, this is the Wibro. And IEEE 802.16e, this is the WiMAX. Actually, India in that time having two options. One is the fiber optics in the WiMAX. Another one is the 4G LTE, but India chosen only the long-term evolution for 4G networks. Because of that, the WiMAX, this is fiber optics based, and this is this is the highly costly. So that's why we are unable to handle it. But in our superior country, like means the Korea and Singapore, they are using the WiMAX. But in India, till now, 28 gigahertz is implemented under the 5G architecture. So blockchain, what is the strength
I did not
and
know.
weakness and opportunity in threats? And strength means this is the cost efficiency and faster access of the medical data.
Excuse me,
Because of
sir.
that,
Slide are not changing.
oh, now?
No, sir.
Oh. Which slide right now? Blockchain first.
At present, showing the roadmap definition and roadmap slide.
Title slide.
Not
Definition and roadmap, sir.
I think you were in second slide, sir.
Second
yes.
slide.
This is second slide.
Sorry. Now, okay.
Okay, sir. Now,
Now, okay.
Yes, sir.
Is it okay?
yes, sir.
Like the change option. Hello.
Hello?
Slide. Hello.
Hello, sir. Hello, sir. Hello, sir. Hello, sir. Is there any network issue?
Now is okay?
Yes, sir. It is okay now. It is okay now.
Hello.
Hello, sir.
Hello.
Hello, it is okay, sir.
Okay, okay. Changing.
The slide
Yeah.
is Green Iot.
Yeah, sir. Changing, sir. Okay, continue, sir,
It is
please.
changing.
Now you just see, and after that you will start. Just see. The act we have discussed. This is the basic security mechanism. And this one is the smart society based mainly the different sectors and how to enable the security. And this slide for transferring the health information. So what kind of different attacks and threats we have discussed in here. And another one, some major challenges when we are sharing the data through the IoT-based IoT devices. Okay. So this is the blockchain strength, weakness, and opportunity and threats. And here, strength means the cost effectiveness, and cost and time. It requires the less time for smooth transaction point of view. And different opportunities is involved, like low fraud rates in the medical supply chain, and beneficiaries get control over the data. And some anonymity of the data will help in the medicinal research. And weakness means less number of software and system vendors are there, not much scalable, and lack of storage capacity and for large amount of data. This is the one of the biggest issues nowadays when you are working with the cloud computing or fog computing. These people will know better. This is the one of the major limitation for blockchain for storage capacity. Okay, to capacity we know this is the soft capacity and hard capacity. Based on the multiple access, how to put a data frame into the shared common channel in the help of the frequency division, multiple access, time division, multiple access, and code division, multiple access. But in these techniques, having the soft capacity. Okay. So that's why our intention is that how to improve the capacity, how to enhance the capacity. Maybe this is the soft capacity. Hard capacity is not possible in here. And as well as threats, hesitant to the social adoption of the technology, non-standardization, and cultural and trust concern adapt to the blockchain for sensitive data, and interoperability issues are involved in this blockchain-based security systems. So here two parts. One is the Internet of Medical Things, means IoT in healthcare. Another one is the blockchain. IoT in healthcare mainly depend on the chronic condition management, and blockchain the supply chain traceability and recall. Medication adherence for IoMT and blockchain is the credentiality. Another one, the remote patient monitoring, blockchain mean claims adjudication. Asset monitoring, clinical research belongs under the IoMT, but health plan enrollment, business to business collaboration, and how to process the business data to the cloud, how to access the data, how to access the business data from the cloud. Okay, from payer to provider, provider to payer. This is the means your client server means your client organization and server. So that means this is purely the B2B collaboration. And blockchain mainly used for strengthening the means business to business process using healthcare data or means any industry data. Or one recent paper published in the IEEE recently, that is the anonymity preserving IoT based COVID monitoring. Several, there is a more number of papers already published for transaction and other also. But this is the one of the interesting paper. Here we have applied the blockchain concept. How to monitor the COVID-19, how to process the data, okay, for means the societal data, COVID-19, that means this is the societal data, and to the cloud. Based on this, we can apply some ontology, disease data mining systems, and then some prediction tool we have designed. And one patent already means granted. This is the international Australian patent based on this. So IoT applications, that is a home, transport, and different community, national, and healthcare. Okay, for any time, anything and anywhere, in the help of proper sensing, analytics, even data-driven solution, and visualization tools. So here one suggestion is that if you will use some Python language, so visualization is means far better. So visualization and data analytics. Under the data analytics, visualization is the one of the major part in nowadays. It's the one of the interesting research area. Okay. Next, Internet of Medical Things. Internet of Medical Things, mainly the IoT in healthcare and IoT in medical area. So in the era of modern medical science research, there is a significant trend in developing a consortium having experts from various fields like computer networks, medical imaging, advanced communication system, Internet of Things, cyber physical systems, all to achieve easily accessible and affordable and rapid smart healthcare system for providing better healthcare delivery. So this is mainly belongs under the Internet of Medical Things. It increases the human machine interaction and enhances the real-time data. You know, the modes of communication is two types. One is real-time transmission, another one is the store and forward approach. Real-time data processing, another one is store and forward type of data processing. So in the telemedicine, in the help of electronic health, m-health, personal health, here you can consider the real-time data. Okay. So IoT, the network connected devices that senses the vital information. And here Wi-Fi can be used in here. Wi-Fi means .11 technology and .15 technology can be used in here for acquiring the data from acquiring sensor to coordinator. Later I am coming for improve the patient engagement and identifications, identify the patient needs, improve the decision making, reduction of the healthcare cost, and closing the patient and provider communication gaps. And in this diagram, basically year versus in means in US billion to expected in the CAG rate 37%. USD means to USD to 156 billion in 2020. This is the market space. So day by day, from 32.4, it increased to 156 billion. So that's why this is the biomedical devices. Okay, 31 billion devices and 4 billion people will be connected by 2020. But in 2036, there's a 31 converted to 105. So new type of sensor technology and advanced data analytics and healthcare structure are associated with this journey. And IoT, here that is the first top point. This is the analytical solutions. Always think about think from the OSI ISO layer perspective. Top layer, upper layer, middle layer, and lower layer. So here in the IoT structure is that on the upper layer, that means analytical solution like a server and cloud. And these are processing by handling the real-time analytics, real-time data. And the middle part, this is the means the device connectivity of and data management like database solutions and network devices are there. Many type of network devices are there. Okay. And lower part, this is means security and controller, interfacer, sensor. This is basically for object. Lower part, this is basically for object. So IoT here, major limitation. Advantage we know, mainly real-time interventions and patient become more beneficial and cost reduction, reduce the mobility and financial burden. Okay. And you can go through Google site and search in the IoT for COVID-19 monitoring. You see the several number of papers are there. Okay. But main motivation is that is a smart sensing, smart processing, and smart data analytics. Intelligent, how to use, how to process intelligently. This is the main part. Okay. And see here, that is a blockchain told you here, this is the operation case, operation theater, and next your mobile app. You can design one app in the mobile, then laptop. All our network enabled devices are connected. Okay, that means this is the over a diverse network or heterogeneous network. Patient records are there, imaging applications are there, billing application there. So here fully covered by the blockchain enabled IoT solutions. This is the one of the example. So the future of future perspective still a nascent stage of development. Enhance the operational efficiency through growing use of the network devices, and mainly the data-driven decision-making solution is associated with this to empower caregivers to accurately monitor the patient comprehensive the health status, automation in health monitoring, authenticated EHR or personal health records, improves the healthcare monitoring and treatment outcomes, and recent developments of the sensor, network, storage and computing, mobility and data analytics. So that's why I hope that is in future that is will belongs under the IoT framework. Next, some platforms are there. When we are talking about the Internet of Medical Things, we need to discuss the old method or interesting and today's life. Also, we are following the telemedicine systems. Telemedicine means the medical information can be processed over the telecommunication systems. The telehealth means using the internet, meaning information communications technology, ICT. How to play the important role for transferring the data under the ICT. That means the telehealth. Okay. And telecare means this is the remote, how to improve the rural healthcare by using the communication mode. This is known as the telecare. Remotely caring the patients and diagnostic also, diagnosis and therapy. Okay. So main problem is that why telemedicine is related, the unavailability of the doctor, nurses means in urban area or semi-urban or rural area, villages. A waste of time and money by villagers and urban poor for appointment. When you are moving to any nursing home doctor, they have taken some lot of some time. Next, non-emergency referral case, this is a more or less 75, and that's why this is the need for the telemedicine system for mitigating the for avoiding all of these issues. As per the WHO report, approximately 17.5 billion people die due to the heart attacks each year. More than 256 billion people suffer from the diabetics, and it is prevented by the help of the W-band. W-band means wireless sensor network. We discussed. W-band means wireless body area sensor networks. WBSN. In our body, that is some several number of body owned sensors are there. They are accumulating the physiological parameters and processed to the coordinator in the help of communication mode. So that's why in the medicine domain, this is the third largest market for the wireless sensors. So this, see the diagram. Next, this is the real scenario and motivation why ML, EL, and telemedicine, telecare, and IOMT, why they are more dominant. Because of that, this kind of real scenario we have been facing in our real life. And this is definitely for automatic, means electronic health record. We are fully going to the automated society. Or automated means that is in our smart society. One point is that this is the paperless society, green society. Okay, each and every transaction like a Google Pay, Paytm, each and everything means using this kind of software by using this e-transaction basically. So we are avoiding the hard document. So that's why proper security mechanism is required. So that's why our intention is that we need to put some blockchain enable technology. Because of that, we are playing with the e-content. We are handling the e-content. We are avoiding the hard document. So that's why proper security mechanism is required. Okay. So this is the different applications are associated with the telemedicine, like telemonitored home care and disease management, disaster management, and continuing the medical educations and disease surveillance and remote consultation. So this is the sectors are associated with the telemedicine systems. Here, actually, one example is there. This dotted line means this is the lease line. Suppose one village, suppose Ayodhya village to Delhi or Calcutta. This is the town, this is the city, and this one, this is the rural, means the village hospital kind of. So you are sending the data, that means your bandwidth requirement is low. So lease line is 512 kbps data rate. But city to city, when you are sending any kind of data, so lease line more means bandwidth requirement is high. That here lease line is 2 Mbps. So that's why dotted line and this line, because of then rural to urban scenario, lease line data rate is significantly low, but city to city the data means data transmission means the bandwidth basically this is high. This is 2 Mbps for transferring the large volume of data. And one application is that this is the means robotics telesurgery basically, telesurgery and remote surgery basically. So this is the biggest important example, interesting example is the IoT. Here IoT and robotics technology are means embedded together to provide the ambient sensing, ambient intelligence, localization, and to utilize the new classes of the applications. It consists of the 4 major characteristics like mobility, means it is possesses some from the mobility, programmability is required, and sense the environment rather than merely function of the data processing, and flexibility. So that's why mobility, programmability, sensor, and flexibility, these 4 terms associated with the robotics. Robotics means multiple objects. Robotics of robotic things means multiple objects. So object means sensor having different type of emotional or different type of means expression. So our intention is that how to accumulate or how to gather the different symptoms, different expressions to the coordinator, and how to process to the internet in the help of IoT. Okay. So this is the main objectives in here. Mainly to understand that the healthcare industry is the forefront of the technological revolution, massive range being driven advanced in the robotics, diagnosis monitoring, means electronic medical records, electronic health records, and patient information systems and digital imaging technology. And also it maintains the electronic record, personal health record, PHR or EHR, for enhance the reliability, the reliable security structure. And here you see the artificial limb is there. Okay. And here each and the movement, that means the motion sensor are associated with this. Motion sensor that is belongs under the WWAN. So how motion sensor data processed to the cloud? Means this is no need to process the data to the server directly. I told you at the beginning. Our intention is that we will process the data to the cloud directly. So that's why processing the data and accessing the data from the cloud. And if you would like to apply some security mechanism, then you can consider some fog architecture, fog computing. Okay, so here the motion sensor is there. Movement related information can be processed from the motion sensor to the cloud. In robotics in healthcare, basically 3 parts. In healthcare, one is the surgeon, hospital, and patients. Surgeon means improve the patient care, enable the complex tasks. Okay, true life or 3D visions, enhance when accelerate superior the ergonomics, comfortable seated posture, less blood loss, and hospital mean increase efficiency, reduce cost, and potential reduce litigation and marketing tool. But in patients, is more vital, shorter hospitalization, reduce pain, faster recovery, and smaller incision insulting in the reduced risks. So these are points associated with this. Each and every sector, there is the need. So who will fulfill the need? That means IoT-based solution, IoT-based medical systems, IoT based robotic systems. Okay. So here the Da Vinci operation is there. This is the some screenshot I have attached. This is Da Vinci first telesurgery robotics. Remotely the remote patients can be treated by the expert that are coming that are belongs to abroad, like you will say, or any other country. Long distance, they are dictating and they are doing this kind of work. This is the one thing. Another thing is that this is the automated robotic solution is there. That is, this is known as the Tele-surgery robotics platform. This is known as Da Vinci operation. See, here doctor is remotely operating in the help of the robotic surgery. In 2001, a doctor in New York removed the gallbladder stone in 68 years later. Same case for 3D vision, master controls and camera control also. This is the disadvantage, mainly the high purchase and maintenance cost. Because of that, we are unable to set up in our country. This is the high cost, but this is performance is excellent because of that. Fully, this is artificial intelligence based advanced decision making systems are involved in these systems. And this is future robotics. In here, this is the biomems and MEMS architecture. MEMS, biomems, biochips, or system on chip, SoC, network on chip. Okay, so that's why some biological aspects and network and engineering aspect, they are merging one a common platform. This is known as, I think, this is the Internet of Robotic Things. One tissue-based, tissue and technology. Okay, this is the one of the example you see in the figure. Next, we'll discuss some communication. Till now, we have just discussed the real scenario, the different applications. But in the communication, this is the one of the important area under any kind of data processing. Okay. So see in this diagram, that is a 3 networks are there. One is LAN, local area network. I told you this is the .11 technology, and IEEE 802.15. This is the wireless personal area network, WPAN, or wireless passive area network. Another one, this is the MAN, metropolitan area network .16, and .20. That means this is the W1, wide area network, means country to country based data in the help of some exterior devices, in the help of means AICTE gateway. Okay. And the left hand side, you see this is the journey from means Ethernet, RFID, ANC, LowPan, and Zigbee. Zigbee here, this is the .pan. .15 this is the means wireless personal area passive area network. Then ultra wideband and Bluetooth 15.1 and WiMAX .11. Next, these are the technology for 3G and 4G LTE. Okay. So here communication mode means it consists of two parts. One is the short range communication, another one is the long range communication. Short range communication means this is the .11 technology, this is the WLAN or Wi-Fi wireless fidelity, and .15 technology, that means Bluetooth, Zigbee, means Wibro, and ultra wideband. Okay. And next slide, this is a long range communication technology. Here means what is the history of means the communication systems, like in 1836 and 1837. This is the time for the telephony and telegraphy systems, and then in 1894 this is the time for means radio communication invented by the J.C. Bose. And next 1920 this is the time for the analog communication, and 1936 to 1940, this 4 years. 1936 to 1940, this is the digital telephony, and after that 1960, You know, this is the integrated circuit IC in the help of the VLSI that is dominating the market. And then 1970 onward is the zeroth generation communication system came into the picture. Next 1971 in the help of the advanced mobile phone system, the first generation cellular systems, the analog communication based communication system came into the picture. And data rate, and after that in 1982 to 1988, this is the time for means the global system for mobile or group special for mobile. Okay, so that's why this is the 2G systems. And after that in 1990s, this period, this is basically for the multimedia data handling. Multimedia means suppose VoIP, voice over internet protocol. It consists of the several number of protocol, like one is the SIP, session initiation protocol, and to initiate, to process, to terminate the session as soon as possible in the help of the session initiation protocol. Or you can say the short range video conferencing, audio conferencing can possible in the help of the session initiation protocol. And another thing is that H.323, H.323 can be used for long distance video communication systems. Then 2001 to 2003, this is the time for the third generation systems. So mainly the conferencing over the long distance using WCDMA wideband code division multiple access. And you know, in 2010 onwards, that means this is the time for the 4G cellular system in the help of long-term evolution. Okay. And next in 2020 vision, and that is beyond 2020, this is the green technology, green society. Why green society? This is coming from the green technology. So first we need some the technological revolution that already been started the 10 years back. So now I am in the beyond 5G and beyond 6G. That is many research is also going on for 6G, but specifically you can say this is after 4G. This is the 5G and beyond. This is the one is the revolutionary technologies. Okay, in the help of this, if you improve our communication systems, then definitely we can improve each and every sector, like industrial sector and healthcare sectors. Okay. Next, in this slide here, that is just some IoT devices are there in general, and the IoT devices and sensors are there: street light, connected car, laptop, or CCD. So that means this is the each and every device is having the data, having the information. What type of data? That is important data. So important data means need some sort of security. Definitely yes. So secure data can be processed to the cloud via fog nodes. So that's why here I mentioned the fog concept. Because of that, we are sending the valuable or important informations, the vital info. You can say vital information, or emergency information. You can say. So from when you are transmitting any kind of means the vital information by emergency data from one node to another node, another node to another node. So that's why in that case, fog node is required for protecting the data. Okay. Second, IoT and the hyper-connected society. That is the first point, the embedded systems, embedded IoT, and embedded means ECU by airbag, ABS, and sensor actuator nodes associated with this. Network embedded system like a communication vehicle controller or intelligent street crossing. Then CPS, cyber physical system, I told you belongs under the 5G. And this is the one of the means your physical to real world interaction can possible. This is the medical device systems. And after that, intelligent environment and smart space, the intelligent environment and smart space, and all these are belongs under the Internet of Things. Okay, this is the IoT hyper-connected society. Because of that, we are discussing the green society. So that's why I have mentioned in here. Next, when we are talking about the IoT and data processing, so first need to check the different type of existing vendors, like a means Salesforce IoT Cloud. And here I personally worked on AWS, Azure, and another one is the Google Cloud IoT. In my student also working in the Azure, I mean AWS IoT analytics also. This is very good, but AWS IoT core support HTTP, MQTT, and WebSockets. Okay, one by one I am discussing because of that IoT AWS. Time is a constant, so that's why need to speed up. So HTTP means Hypertext Transfer Protocol. Okay, but Hypertext Transfer Protocol, that is application layer protocol. But we are using HTTP now. Question, answer is no. So why? So which version you are using? You are using HTTPS. That means secured HTTP. Next, MQTT and WebSockets. See, next slide. Here, MQTT is the automatic light control. This is the node RED connected with the one board. This the chip is there. So it sends, that is a read and publish message. I am coming probably in the next slide, I think. Okay. So it is works the top of the TCP and IP protocol. And TCP IP protocol means, see, that is we want to recapture means once just for OSI ISO structure. You know, apart from this slide, I am discussing the OSI ISO structure. First, lower layer of the OSI ISO structure, this is the physical layer. What is the purpose of physical layer? It transmitting the bits. What is the example is repeater and hub, regenerator, reamplifier. Hub, the multiple number of means hub means this is the intermediate device. Second layer means data link layer transmitting the frames between source and destinations. What the example means your bridge, switch, and bits. Okay, and one frame consists of the several number of bits. One several number of frames. This is known as the packets. So network layer means packet. Router is a device. So transmitting means transmitting the packets from one node to another node. This is the network layer. And transport layer means transmitting the segments. Transmitting the segments, one means user to another destination, one source to destinations. So two parts. One is means your TCP/IP and UDP. UDP means user data connection protocol. You can transmit the large volume of data in an unreliable way. And another one is there. This is the STTP. If you like to transfer any kind of streaming data, so that's why you need to consider in this one. And beyond transport layer, this is the upper layer. So that's why I can say, okay, so node to node communication means this is the lower layer. Process means your host to host communication means this is the middle layer or network layer. And process to process communication means this is the transport layer. So that means this is the 3-layer perspective. Clear? Okay. Next. Okay. Here, this is the means your MQTT basics. MQTT basics means this is the mobile means your telemetry protocol. Here publish and subscribe. Publish and subscribe means nothing. Like one side is the client, another side means your the server. Okay, so client sends the request message to the server, and server receives the request message and then generates green acknowledgement. Same case, client sends the publish message and so means like server means send back to the subscribe message. Okay, after getting this, only you can control the automatic light on off. This is the one kind of home automation. MQTT protocol mainly used for the home automation. Okay. And HTTP, same case, one is the browser, another is the server. HTTPS we are using in nowadays. And mode of communication means this is the full duplex communication. You know, mode of communication is 3 types. One is the simplex communication, another one is the half duplex communications, another one is the full duplex communication, like I said. One duplex communication pager, only this is. Okay. Next, IoT communication technology. IoT communication means things means objects. Objects connected with the means your local area network or local network. Local network process the data to the Internet of Things means internet. Internet means the database and applications. Backend services are associated with this. So that's why device to device connection is required in the help of Zigbee, Bluetooth, Z-Wave, or you can say this is the .11 and .15 family. Okay, that means this is the device to device means node to node communications, but node to coordinator. Node to coordinator means device to gateway. Device to gateway. So that's why that is an interworking function or gateway. This is means highly essential for acquiring the data. This data is coming from the multiple number of sensors. And gateway to cloud communication or directly device to cloud communication. This is the second, the third part. Another one, some backend data sharing model. One is the means front end model, another one the backend model. Okay. And OSI ISO structure we have discussed. This is the application means the IoT layering structure. It is the means 4-layer architecture. But here purpose is same. Node to node communication, host to host communication, and process to process communication. So that's why in the lower layer means this is the sensing layer. Lower layer means this is the object oriented layer. So that's why this is known as the sensing layer. This is the multiple number of sensors associated with this. And then we need to find out the path. So path finding and having some lookup table, that is means the third layer of the OSI structure. The main advantage is that it is having their own lookup table. So that's why not only routing the packet, not only finding the shortest path, this is also maintaining their own database. So that's why, and as well as assigning IP address, class A, class B, class C address, and as well as you also familiar with the IPv4, IPv6. But difference is that IPv6 having means the multiple number of extension headers. This is highly beneficial for us. Okay, so as per your requirement, you can transmit the data by using the number of the extension headers. Clear? Upper layer, that means data processing layer. That means this is the network layer. Here, some data-driven approaches are involved. Knowledge-based concept are there. Even handling the model and the semantic reasoning the data, machine learning and knowledge-based data mining concept using the hybrid approaches you can apply in here. And after that, your upper layer is the application layer. Okay. So our main intention, main part is there, that is a data gathering, data means acquisition. After that, client and host identification, then faster communication system, faster data processing. So in the help of the means your data mining, artificial intelligence, some adaptive techniques, some different learning analytics like a supervised or perhaps semi-supervised concept. Okay, and then your application. After that, you can means get the superior the better performance of the different applications of the system under the societies. So smart societal learning concept we have discussed means your OSI, so layering structure 7 layer, TCP/IP 5 layer, IoT structure 4 layer. You can say 3 layer, no problem. But in smart society layering concept is seen based on the applications. Based on the applications, mean upper layer of the IoT, upper layer of the OSI, upper layer of the TCP. So that's why smart societies layering concept is that in the left-hand side services and applications, including security and management. So application means apps, software, analytics, integration, interconnection, acquisition, infrastructures. Okay, infrastructure based and infrastructure less. Infrastructure based means just think 1 minute for WLAN, wireless local area network. Actually, in 1901, the Italian physicist demonstrated a sheep and shore method. So from this is going means coming to the dash and dot approach. So that's why for system interconnection, wireless WAN, wireless MAN. So that's why it is the WLAN mainly consists of 2 parts. One is infrastructure based and infrastructure less. Infrastructure based means 3 laptops connected with the one device by wired. That means one server is associated with this. This is known as the infrastructure based. But directly laptop, directly end user are interconnecting or communicating each other. There is no server concept. There is no server. This is known as the infrastructure less networks. So that's why infrastructure is required. Proper infrastructure is required, and you have to justify why infrastructure less is better. Even transportation system, even healthcare system, even in the industrial perspective. Acquisition like a sensor, in a camera image sensor is there, and I will give you the one means work. So here that is a how real sensor by image sensor can work. Okay, this is the interconnection. Already we have discussed different short range and long range communication are involved with here. Integration is required among the sensor data and economic, billing, population, mining, and GIS, your geographical information systems. Analytical, machine learning, deep learning. So that's learning and predictive learning and analytics. Machine learning or deep learning with the predictive analytics. So analytics, integration, interconnection, acquisition is highly required for this structure. Next, this is the one example here. Here, telewound monitoring system. Telewound means this is ulcer. Telewound means this is a ulcer, and ulcer means your dermatological problem. So that's why here you see the patient mobile unit is the mobile, means here the mobile app is there. It capturing the images. This is the ulcer images, and it sends. Okay. In this slide, basically, I'm going to here I've applied some compression mechanism. How to improve the compression mechanism? One second. One question is there, that is which are the IoTs can be used to maintain the environmental sustainability in university? It depends. First of all, you need to see that is what is your requirements. IoT and model. IoT model is not fixed. By IoT and model, you can go to the market and buy one thing is no. So IoT means first you need to set up your network related but device related issues. You need to find out that this is our device, this is our requirements. Okay, and then how to then first need to design the means or model. This model basically it is consist of means several number of devices are there. Then you see that is what is the requirements, like energy. What are the performance criteria? Based on this, you need to use the optimal number of devices for that data processing to develop, to maintain the environmental sustainability. Okay. So here that is the one compression is required. Compression means that is this is the societal information like a medical imaging related. Here, if we transmit the original image, it takes the large bandwidth, JPEG low bandwidth, size versus bandwidth, and crop version. So these images is acquired by the telemedical hub. So one database is there, wound database. Wound database means wound related information is stored with this sector, and it is consistent of the image processing. So see in this slide that is a set partitioning hierarchy tree. This is the efficient and powerful and compact techniques for improve the performance. And JPEG is also be there. And crop, you can means manually you can crop the images. So that's why in this kind of images can be processed over any channel, like a WGN channel means additive white Gaussian noise channel. This is means the ideal channel. And BPSK modulation where we are using because of that for long distance communication, BPSK performs well rather than QPSK. Okay. See, this is the general this is the one of the comparative results, like how simulated bit error rate with the theoretical bit error rate. So bar versus the SNF bar. So this is the improved for simulated bar. Okay. See, this is the main important slide here. How IoT can monitor wound healing. I am coming to this point. Wait, I'm not finished. First, finishing the whole slide. A lot of things are there. Okay, just when discuss the basic things, but question answering, I am coming to the last part. Okay, I am not finished yet. So that's why here means original image see the 768 kb, and here that is we means improved the accuracy of the model, like the segmentation accuracy and different other parameter like the sensitivity, and other the dice coefficient also. Crop means crop images 20 kb, JPEG compressed image 39.7 kb, and SPHT means 18 kb. That size less size, low size accuracy is high. High size accuracy is low. So that's why SPHT compression methods is considered in here based on the segmentation accuracy. So that's why here we can improve the efficiency of them. So I told you for any kind of smart health, health 4.0 architecture, here we need to improve the efficiency of the model. Okay, so energy and efficiency we can manage in the help of the proper compression method. Next, this is the means WSN in the IoT, sensor cloud, EL, ML, decision making, and I hope you will get your answer from this session. WSN means wireless body area, wireless sensor network. This is the important element in IoT paradigm. Facilitates collaboration of the heterogeneous information. Main characteristic is small size. That is, you have seen in the last slide we have discussed. If size is small, you can improve the segmentation accuracy. I'm not discussing about the classification accuracy. So size less, accuracy is high. That means you can improve your means efficiency of the model with minimal amount of energy. So tetherless, low cost, constant by the energy and computation. Okay, and communication systems. So here see that is a 3 networks are there. One is the independent network, like a WSN directly transfer to the internet via a gateway. One gateway is involved. Another one, WSN and internet, in between multiple number of gateways are there. But you can't assure all gateways belongs the same distance, no. So that's why you can consider in here means your Manhattan distance and Euclidean distance for implementation point of view. After that, last part, this is the hybrid model, the hybrid structure. Okay, so that's why this is the hybrid or clustering concept is there. That is, this clustering means this is the autonomous system. Autonomous system means this is the one area, one set where the multiple number of devices belongs under this area that are mapped to the directly to the internet. Okay, so that's why means means software specific applications kind of things here. That is just some different sensors are means associate with the cloud assisted healthcare system or any system you can say. So that's why this is the one amplifying optical amplifier in there. How to amplify the signal? So sensor as a service. Okay, so sensor, mostly sensor taking the proper decision in any sector for developing the sustainable city. Okay, so in this case, basically, like means means a pandemic like coronavirus. Here there is an urgent need for changing our traditional healthcare monitoring system, and which produces lot of waste and pollutes the environment. Okay, so that's why that is in somehow the instead of the bulky instrument, this wearable microsensor can be embedded and attached with the patient, and it can monitor the patient's health remotely using modern computer and electronics technology, like IoT platform, and including means the computer vision, VLSI, big data, deep learning, machine learning, artificial intelligence. It will become the real-time health monitoring systems. Okay, so that's why you can say this is the internet of the things or internet of sensor thing because of that sensor. Without sensor, you can't handle the data. This is the body area network we have discussed in earlier. WWAN in the same case, wireless body area network. So in this case, that is some various issues or challenges associated with this. And emergency medical care and reliable transmission of the vital patient data, low cost and better quality of the service. One thing is there in the how to improve the quality of the service during the communication systems. That is some delay will occur and variation of the two consecutive delay. This is known as the jitter. So delay, jitter, packet loss, throughput, reliability, and utilization, list utilization is better. Sum of all this is known as the quality of the service. And anyhow, you need to improve the quality of the service. Okay, and as well as that is a low complexity is better and proper standardization is highly required. This is means some sensor type different body means WBSN sensor, ECG, EMG, glucose monitor, temperature, motion sensor, voice, capsule endoscopy, and medical imaging by image sensor is there. Okay, as well as I mentioned some data, rate, bandwidth, latency, and accuracy, some reliability aspects. 10 to the minus 3, the image sensor, if you use it. The mobile sensor basically, in a mobile you are using. So sensor cloud of things, that is a sensor grid, multiple number of sensor, sends the request message or publish message. So in between IoT cloud is there. It is some commands associated with this control, subscribe, notify, and unsubscribe. It is sent to the notify, client application, enterprise app, desktop client, and in means client application, web client. So that's why means sensor grid to IoT cloud controller by sensor services. This is mapped to the distributed access to sensor or service driven sensor data. Here, this is the one problem, real-time problem. This is the chronic wound monitoring. Here, I have considered Internet of Things. That question you asked a few minutes back. Because of that, I process this data to the cloud directly. There is no server. Here in the body, having multiple number of body-owned sensor, I acquired this data. This data is processed through the coordinator via a short-range communication technology. And this coordinator transmits the data over a long range. What is it? 60. Sorry. So that's why coordinated to long distance 2G, 3G, 4G, and beyond. Then right hand side, three things. One is the data acquisition part, WWAN phase 1, phase 2 access networks, phase 3 e-health data and processing center. So here chronic wound data is transferred directly to the cloud using different kind of fog nodes. Because of that, for appliance and security. Here we have applied some compression techniques for improving the means your performance, improving the efficiency. And right hand side, your server side, that means telemedical hub is there. Telemedical hub is connected with the cloud. If you need any kind of data for manipulation, medical imaging, two sector. One is the database, another one is the medical imaging center. I am coming. So that's why IoT means your body-owned sensors directly transferring the data from sensor via coordinator to the cloud. So that belongs under the IoT framework. Okay. And IoT belongs under the IoT framework. One is the automated means patient ID allocation scheme is also involved in here. Mean unique patient ID number is also identified in here, and as well as source and destination IP address is automatically identified in the database. So each and everything is automatic. Okay. This is the mHealth and eHealth. So that's why in the mobile I've created one app. This app consists, this is known as the metadata app. This metadata, mobile metadata app consists of two parts. One is it acquired the medical images, and right hand side it is having the clinical information, patient information. Both are embedded together, and you can transmit the metadata. Your means your server side, it receives the metadata each with respect to the each and every patient, and patient information stored in particular with respect to the particular patient data to the database, and medical images going to the medical imaging toolbox. See, this is the screenshots. Okay, screenshot means medical images, how to develop. Okay, so here you see that is one paper is there that is recently published, the role of smartphone in IoT framework, the Springer energy conservation IoT device concept 2019. Here clearly they mention how IoT play the important role, how smartphone enable IoT system can play the enable means your better role for transferring any kind of medical images. Okay. Decision making means, you know, the artificial intelligence. I am not going to the in details. Just main point is that is a for decision making system is required in the help of the artificial intelligence, like emotional intelligence or patient physiological parameter changing information. Okay, so that's why this kind of proper decision making unit is required for processing one node to another node. Okay.
Hello, sir. Hello, sir.
Sir is not there, I think.
I think he may be disconnected, so we will wait for him. He will join very soon. Hello, sir.
Hello, no sound is coming.
Hello, sir. You are not audible. You have joined, but you are not audible. I think expert is facing some network issue. So please wait.
Host disabled participants screen sharing, right?
Hello, sir. Now you're co-host. You can share your screen.
Okay.
Okay, sir.
Okay. Sorry for this network issues there. So AI in health basically for collection of the multiple technologies, enabling machines to sense and comprehend, to act, learn. So this is mainly the increase the interoperability between system, end user, and electronic medical records. An application point of view, image recognition, interpretation, diagnostic systems, assistance, and generating the reminders and alert, and benefits the fast and accurate diagnostics, reduce the human error, cost reduction, and virtual presence and telemedicine. And this is the one side is the clinical demand and clinical supply. You need to balance with the supply versus demand in any sector, industrial sector, in healthcare sector also. So that's why 20% of streamed unmet demand addressable in by artificial intelligence. Okay. Next, computing versus green IoT. Here you see human-centric devices generating data. Okay, this is the above 5,000 millions per unit. And in the year-based means PC notebook and means ultra mobile and mobile device. And another thing is that IoT device generating the data. See, this is the massive difference. Okay, in 2020, this is started from mid to 2016 and 17, and now IoT device generating data is, that means this is the massive data. Okay, that's why you can say this is the massive data fusion. Okay, and machine learning. Machine learning means your for classification perspective. So major breakthrough for the meta pattern recognition, some regression and so classification techniques. So the computer program is said to learn from experience E with respect to some class to task T and performance measure P if it's the performance. So that's why learning analytics or machine learning, or you can say this is deep learning, you can use for classifying the data. Okay. See, we'll discuss in the next slide with the one problem. In this learning structure, the learning algorithm mainly used for the different sectors. Means your clerical, customer, education, healthcare, science and technology, IT, managers, finance and legal under the society. Okay. So main terminology is there. Main objective is there for unsupervised learning. That is in supervised when the output is a finite set of discrete categories. This is known as the classification. Label or continuous variable, this is the regression. So one is the classification, another one is the regression. I am coming. The next slide. And discovery of the internal presentation of input data to transfer it into the new variable space for further processing, like a machine learning algorithm is known as the feature extraction. Okay. So different algorithms are used. This is the more vital or important. This is the KNN algorithm mainly used for the classification, name-based classification, SVM classification, linear regression for regression, SVR, support vector regression used for only the regression method, and classification and regression trees only used for, that is a both case, classification as well as regression. A random forest, classification and regression for data processing tasks, and other machine learning algorithm like bagging, okay, bagging, decision tree, and the index, Gini index, measuring the classification regression, K-mean clustering, only clustering, density-based spatial clustering of applications with noise clustering, PCA, feature extraction, and CCA also the feature extraction, and FFN and neural network, regression, classification, clustering, and feature extraction data processing tasks involved with this. And one class support SVM problem, SVM machine learning architecture used for the anomaly detections. So that's why in this slide, basically this is the more important, because of that. That is, if you can apply means any kind of clustering techniques. So that's why here you can choose it based on your regression and classification method based on your regression and classification method. Okay. So benefits of the IoT healthcare: cut down on the medical cost, improve the patient experience, enhance the manageability of the medical drugs and medicinal adherence, and dramatic reduction in errors, and better control over the wastage in the healthcare sector and better outcomes of the medical treatment. So these are the part are associated with this, but to improve the healthcare sectors or any other sector also similar to this. Here I am discussing only healthcare. You can apply the same concept for the other sectors also. So you will see that you will improve the same benefit also. Okay. Next, that is a one summarial point of view, that is a here different IoT, cloud, IoMT, data analytics, WWAN, and AI. Already we have discussed, but somehow that is our expectation is that is a 5G enabled solution is required. We need to develop a smart city, cyber security, edge and cloud computing with hybrid deployments and augmented virtual and mixed reality concept. This is the emerging or upcoming technology. Okay, these are associated with this. And one real-time problem, one case study related, two case studies there. That is the first time to see that is the epileptical seizure detection using the IoT. Okay, same case, same that is a you asked the one question means high IoT is associated with this. So that's why I have given this case study, two case studies there. What sub part already we have discussed. This is another problem, performance analysis of the gamma band EEG signal using the means short time Fourier transform. My one PhD student is working with this. So seizure detection means this is a defined of sudden synchronous activity of group of neurons to produce the sudden spark of the brain activity, and repeated seizure, this is defined as the epilepsy. Okay. So see in the first two sentences, because of the rest more or less same. So seizure means sudden synchronous activity. So this is the activity monitoring stage. Activity monitoring, repeated seizure is defined the epilepsy. So we need to monitor, okay, using the Internet of Things. So here you see that is in this picture different brain areas and functions are associated with this front lobe and parietal lobe, temporal lobe, and occipital lobe and cerebellum. So EEG and the means electrophysiological parameter monitoring method to record the electrical activity and this electrical activity of the brain. So normal activity of the brain, abnormal activity of the brain, comparing with this kind of this set of data we are processing to the cloud directly. Okay, via the invasive means non-invasive techniques, and definitely it is a low cost. Here, considering the IoT architecture, because of that cost is the another issue. Low cost is better. Okay. So in this case, you see that is a easy measure the activity of the large number of population in the neurons. This is first recorded in the Hansberger in 1929. The ERP recording system basically. Easy recording are non-invasive, painless, do not interface much. Human subjects are involved by ability to move for stimuli or relatively low cost. So this data is processed to the ERP presentation system, event-related potential. So in the yesterday technology, they means doctors that is acquired these physiological data and stored in the server only. But now we are processing this data not only the server because of that buffer space as bandwidth is the issues. So that's why directly to the cloud or virtual database. Okay. So this is the different normal and abnormal means the normal easy recording curves. So that's why we are storing in one particular virtual database, as well as we have comparing with the abnormal stage. Then we are finding the difference between normal and abnormal. Then we are measuring some accuracy, and then we are predicting something to the patients. So based on the prediction, doctor can assign the means medicine, and time to time they can monitor. Okay, so that's why this is the picture. See, this is a normal easy. I am not going to the details. I'm just giving the overview. Normal case, partial seizure. See, when the spark is there, and generalized seizure. So that's why first you need to send the normal data, partial data, and generalized data. Then you have to measure how much damage is there. Okay. See this diagram. So this is the model of cloud-based health IoT for epileptical patient monitoring. Here things and devices are there, and this device is acquiring the EEG data. It is processed to the cloud. This is the cloud devices. That is a AWS, this Amazon devices there in my lab also. They are working in these EEG systems. And then the internet cloud for the data storing, signal enhancement, feature extraction and classification is there. After that, secured accessing the data, means the patient information. Health expert is there. Health expert can take the superior decision based on this data storing, based on this data, based on this means patient historical data. Okay. After that, your patient accessing the feedback by patients or caretaker, and service case emergency data and patients monitoring. Okay. So here actually the watermarking algorithm is used in that case. This is one of the compression methods embedded. Because of that, our intention is that is to improve the efficiency of the model. So that's why watermarking is applied in here, but we got the very good results also. Another case study means this is the chronic wound monitoring, and we have discussed wound monitoring means this is a real world real type problem, like a venous ulcer, diabetic ulcer, pressure ulcer, malignant ulcer, and pyodermatous ulcer. So it is based to see that is each and every picture having means combination of three colors. Like one is red color, this is known as the granulation tissue. Another one is the yellow color. I mean, this is the first stage. After taking some medicine, this is going to red color converted to the yellow color. That means RY, red converted to the yellow. Yellow means this is the slab tissue. After taking the medicine, more or less the 6 months is required for retrieve. The black color means this is the repairing stage, black color. So that's a red, yellow, black. That means this is the RYB model. And tissue-wise granulation, slab, and necrotic. Okay. So for conventional but traditional method, this is means inaccurate or painful. So that's why here somehow we need to develop some automated diagnostic tool. Okay. So that's why I see in this slide that is I find out that is a lack of means what is the present scenario, and as well as I have prepared the motivation. So I also encourage to you, when you are doing any kind of research work, just preparing like this slide. Because of that, I found that is a lack of the qualitative assessment. So that's why I enhanced the qualitative assessment based on the color and texture in this tissue-wise information. But I've seen that is mostly dependent on the color. Because of that red white RYB model, this is the variation of the color. Okay. And here no percentage of wound tissue is required, but information of wound tissue is required. This is highly expert dependent, automated expert dependent. No community database is present. That's why I developed in the community database. So that's why moreover in India, that is in developing countries such as India, poor access to healthcare, inadequate the clinical manpower, poor healthcare infrastructure in the less literate rate. Here, need for developing an integrated technology for the wound management. So that's why this is purely the automated diagnostic tool. So automated diagnostic tool is required for monitoring the means your wound by ulcer imaging patterns. Even that is one research work is going on. What is the wound patient, what is the wound affected patient status during the COVID-19? So that's why what is the pattern, what is the changes? So that's why we have already collected a few data. Means we need to develop this more, and then we have to apply. So what is the changes? What is the research area? Okay. For deep learning by any other learning analytics, we have to apply, we have to classify. Okay. Next, this is the international status. International. Here I see that there is no reports. The study on distribution of the tissue type category of the chronic wound. Some comprehensive software for automatic. There is lack of automated tool in national status. Community wound database is not present. Comprehensive software for automated chronic wound is highly required. So that's why in somehow you have developed, means I developed, that is some automated diagnostic tool. In this slide, see that is how IoT play. Because of that, in the left hand side, this is the W band is there, data acquisition module. Data acquisition module, multiple number of body on body sensors is there, smart intelligent sensors. Because of that, we are intelligently acquiring the data by the sensor and processing to the coordinator using the short range communication like Bluetooth, Vibro, ultra wideband, GPS, and Zigbee. Then I have developed the one metadata, mobile metadata. It has consists of two parts already I've discussed. One is information, another one is image. Then we are processing the Internet of Things based TWT network model, Tele technology monitoring model. After that, your CAD tool is there, computer aided diagnostic tool. This is means your own database, fully all are the virtual database. Another part is medical images, the chronic wound images processed to the medical means image processing toolbox. First stage, the pre-processing is needed. Pre-processing consists of filtering here median 5x5 filter I have used it, and filtering, edge preservation, anisotropic diffusion, color space selection, then segmentation, then classification. After that, classified based on the classified results, that is a doctor can take the decision how much percentage of tissue the color is present in the tissue, and based on this is he can prescribe the medicine. Okay. So here the working model, the one side the image acquisition, another side the clinical information, metadata, image with patient information. That means this is the CAD tool by image processing tool. It is belongs under the telemedical hub. And see the next slide. Read the images from the metadata. Then pre-processing, color correction, noise reduction, color homogenization, and color space selection, wound area segmentation, feature extraction, and pattern classification is there. Okay. Here that is a two type of data acquisition. Data acquisition means there are two types. One is the primary and secondary. Primary source, I have collected the data from the Meditech database, online database. And secondary data means that is I have collected data from means district southern hospitals, and one is the from Midnapur Medical Hospital, you know, and 2-3 hospital from the Germany. Okay, and this is not an updated database. Here, that is a 4 type of ulcer patient information is there. Okay, so based on the primary and secondary wound database, I developed that is some benchmark database. So that's why you need to develop the benchmark database where the pixel information is more. So wound acquisition model, because any here that is I am discussing the wound model, you can discuss any other model, no problem. So color correction, noise reduction, filtering, combined grayscale and retina theory is also involved in here. Then color space selection, color space transformation, Y DVDR. Okay, Y luminance and DVDR components, three channels we have considered. Okay, then segmentation module. So see, I'm not going to the details of the image processing right now. So this is the original image. If green channel is constant, green constant in 2 cases. So alpha and beta is varying. This is the gain. So red color and blue color from the original image. This is converted to the red and blue where green is constant. Here median filter given the better performance with respect to the other filters. So that's why in the first case I have considered the median 5x5 filter is used to remove the salt and pepper noise. This is still present in the wound data that are coming through the mobile systems. Okay, so that's why median filter means I have chosen because of that is better performance. After that, this is the color space selection. Color space selection, that is a Y DVDR color space is selected because of that DV channel gives better contrast or high contrast value. So how to measure the contrast? Contrast means that is a YIW, that means this is the imaging case and this is the background case. This is the affected case, affected portion, this is the healthy problem, healthy. So affected minus healthy. Okay, so that's mean this is the contrast, and here means we choose the highest contrast value. So DB channel gives the highest contrast, then DR channel. So why DB-DR color space we have considered, and out of 15 color spaces, RGB and YCBC or YDB-DR, ACI, LAB, here I have seen that DB channel bit gives the better performance. So median and next DB channel I have considered. So see what is the output? Original image, first column. Color correction, second. After median filtering, third. After anisotropic diffusion, fourth. And YDB-DR in DB channel, this is the pattern, and the last slide. Okay. Next clustering means the segmentation method. Sorry, means segmentation method. Here K-mean I have applied K-mean, fuzzy C-mean, and a C-mean. Means spatial fuzzy C-mean. Here see there is a list of parameters. Number of possible parameters I have considered. Segmentation accuracy, sensitivity, this is the most vital, as well as dice and Jaccard coefficient, false PP rate, and false negative rate also means I have considered. Here I have seen that is a number of images is 96. Color space modified DB-DR, because of that I applied some weighting functions in here. Okay, so that's why modified DB-DR, and DB channel is better. My DB channel I have chosen because of that it provides the highest mean contrast value. Next, three segmentation algorithms. Here I have seen that is a DB channel based fuzzy C-mean gives better performance. So that's why that is in the first case 5x5 median filtering. After that, this is the YDB-DR DB channel based on the highest contrast, and third part DB based FCM clustering we have considered till now. Okay, this is the output, original image and segmented image with the cutted region. Okay, see the output. Ground truth means that is some manual leveling, and here CorelDRAW software is used. Actually, ground truth means doctor manual observation. Later I will see you the one validation later, because of that how doctor predicts and automated system gives. What is the difference between automated and manual? So that's why this is the ground truth. Okay, when you are means measuring means any kind of means accuracy of the model, so you need to compare with the ground truth model. So up to segmentation is done. So the next, segmented image process to the feature extraction, then selection of the training data, then classification. Classifier means 4 classifiers you consider: Bayesian, LDL, linear discriminant analysis, and decision trees and random forest. And then decision and classification input, tissue characterization, post processing, and accuracy of the model. Okay, so this is the steps are involved from segmented case to output accuracy. Okay, see, feature extraction means that is a from measurement image data. Tissue region means RGB, red, green, blue, and here 96 images. I told you that is a we are considering a develop in my database, where granulation tissue 35, slab in this, necrotic in this. 7 different intensities informations they have considered, like for extracting means each image database. But you believe that is a in that time that is all of the existing papers they consider nearly 7 to 8 lakhs means your data pixel information. But I developed my own benchmark database. Here 14 lakhs, over 14 lakhs data is associated with this. So that's why if your data strength is high, so based on the high data set, so whatever accuracy you will receive, this is the highly means informative. Suppose you assume that in your class having 10 students, you are saying you are the first boy, or another class having 200 students, another student is saying I am the first boy. So who is the most valuable, most intelligent? That is out of the 200 class, 200 capacity in the class. Okay, So that's why that is a, in this case, the feature selection methods used, which is feature selection minimizes the number of features provided for the classification tasks, and feature extraction techniques can be deployed when the input data is excessively large to be processed and assumed to the redundant. So that's why, see, this is the feature distribution. So feature distribution means how much is highly overlap and how much is less overlap you need to measure. So that's why granulation, slab, and necrotic. Here observation is that when you are considering the red color, here the less overlapping is there. Because of that, the 7 color space we have select 7 measurement parameters: RGB from RGB, LV from LUV, and B from LAB, and HSI color space we have chosen means only H. So here case density plot we have used. Case density plot, we just keep in mind is that is a some distribution of features is analyzed using case density plot, the kernel density, to estimate the probability density function of features with respect to the different tissue classes. So here three class tissue, 3 class problem. Like one is the red color means the granulation tissue, yellow means this is slab tissue, and N means necrotic tissue means your black. Okay, so that's why this is the 3 class problem. Okay, so that's why that is a means from this figure basically it is observed that is a few intensity have less overlapping region, RGB, LV, and some of them have highly overlapping. So that's why here less overlapping are region, and another picture you see, this is means few intensity is less overlapping, G and B. This is the less overlapping. Another one is this is the highly overlapped. So that's why case density plot is applied because of that, to find out but two findings, the nature of the features. Okay, so data distribution of for each intensity profile of different tissues has been presented visually, and some features have fewer overlapping regions. We means consider only these less overlapping data. So it indicates the good features for wound tissue classifications. Clear? So that's why here the classification, the feature distribution part is means we have discussed, and some 4 classifier, name-based classifier, linear discriminant classifier, LDA. LDA here we have considered LDA classifier because of that, for maximizes the class separability on the reduced dimensional space. Okay, and as well as searching the linear combination of the variables, and decision tree means 10 decision trees is considered for creating a one forest. Forest means the random forest, and later I will see that is in the random forest algorithm means provides the better response in this particular problem. And decision tree, you know, this classifier very much powerful and statistical tool, and best suited to the analysis of the complex data. Okay, and we are playing with the complex data. So flexible and robust analytical method like decision tree classifier is used in the medical and healthcare field, or any other field also, but we are concentrating on medical healthcare field. So this classifier is used to classify the instances that is for using means sorting them based on the feature value. Okay, so decision tree are generally unvaried. This is not a varied data. Okay, and random forest is the most powerful nonlinear and statistical classifier used for analyzing and classifying the wound tissue. Here 10 decision trees I have considered, I mentioned. The input side, number of training data set, number of feature space, number of trees, number of classes, and number of testing data. And output is a means so the random means so random forest. Second, see the diagram. Here manually cropped. That means this is the feature extraction part. And right hand side, this is the means your gold standard method like your ground truth image. Here we have considered the Corel Draw. That means this is the manual doctor observation. Comparing with those, here we have seen that tissue-wise means of the percentage, tissue-wise the accuracy, and overall accuracy, sum of all. See the 93% accuracy is achieved in the help of the random forest classification.
Hello, sir. Hello. Participants, please wait. I think the expert is facing some network problem. So please wait for some time. I think he will join again. Hello, sir. Sir, you are not audible.
Okay, so in this diagram you see
Yes, yes.
this is means your original image, then your percentage of tissue is there. So see the one picture or one picture in the granulation is 74. The 74 means red color is 74%. That means this is the first stage of tissue. That means granulation tissue. Granulation means red color, means highly affected. This is the first stage. So that's why, and based on the percentage of tissue, doctor can assign, but doctor can give the medications based on the percentage. So that's why somehow it's better rather than means the manual observation by the clinicians. Okay, and this slide I already discussed some clinical informations. This is the flow map. Okay, this is means some screenshot basically, how to upload the image and how to monitoring the data. This is the database. This data coming from the cloud actually, AWS, Amazon. See the diagram. Here means Oracle platform, SQL, MS Team, MS Access, XML, and SAS8 and PHP MyAdmin. MySQL and PHP is used in here. MySQL and PHP. So that's why this is the community. This is the community-owned database in used in particular the healthcare sector. See, this is means the validation point of view. This is validated from the Germany also, and I sent to this lab and they have validated. Okay, your automated diagnostics tool is helpful, and I have already captured some data from Europe and India together. Okay, with some Russia also. So that's why, as well as means he is also written in that time that I would like to interested as well as in the paper as well as for cooperation. So that's why our joint one project is going on, Indo-Germanian project. So I am the PI from this side for Tele monitoring in the help of Internet of Things. This work is going on basically. And this is the means your expert doctor validation. Expert doctor is given how much accuracy is present as per his naked eye observation, and I have given my automated diagnostic tool result. So that's why automated diagnostic tool provides the better response. This is the one of the good surgeons, Dr. Subhash Chaudhary of dermatology, and this is the MS. So that's why this is validated. And even in IIT Kharagpur, one lab is there, School of Medical Science and Technology, and there I have Dr. Mitra. He is the already professor in the Calcutta Medical Hospital also. So he's validated this data. Okay. So that's why overall main summary is that means your smart society, your green society, and throughout this means the presentation, I have tried to cover some basics like a sensor data analytics and communication, and one is the healthcare problem that is IoT assisted to develop the means your smart society, smart city means different kind of any other application is there, urban sustainability, but food security. Here you can apply the Internet of Things, some disruptive mobility, pre and post COVID times, the app-based shared mobility like Indian cities, or long lost path like developing environmental awareness through the pandemic. Okay, so how to develop the means environmental awareness through this pandemic in the help of the IoT. You can use it. And as well as dual impact on the lockdown, so curbing of the COVID-19 spread and the air quality index, you can monitor it. So pollution controls, you can already monitor. You can apply some IoT concept in here, and different disaster monitoring, the opportunity for environmental sustainability, or impact of carbon dioxide emissions. Here, Internet of Things plays a very good role, and different sustainable means attainment of the solar EOS recycling means concerning with the different COVID or other pandemic crisis, biomedical waste management, and different kind of innovations, trend and innovation in biosensors, variable in healthcare system, biodiversity conservation, and unprecedented blessing for nature, and as well as green economy. This is the one of the another major area means you can apply for smart society. Okay. Any question?
Thank you, sir. Thank you for your nice and informative presentation. So there are some there are some questions. The participants have written the questions on the chat box. So, sir, can I read out the questions?
Already I have given one or two response. I am checking which one. The attendance link also. But previous I think related. It will be better if you copy paste one second.
So, sir, can I read out the questions one by one from the chat box?
Actually, here is the raining, so that's why 2 times the network is got corrected.
Yes, sir. So, can I read the questions from the chat box, sir, one by one, so that you can address the participants?
Hello, Paramita. Is it possible to paste the question again in the chat box? So please.
Okay, so I'm giving the questions once again in the chat box.
Or participants, you can also write the questions again.
How IoT already have discussed. That is each and every slide IoT based. And environmental sustainability at the university level. That is I told you model. First you need to prepare the model. First you need to prepare your requirement, and then you need to find out the optimal solution. Then sustainability means green concept. You need to use the optimal resources. So that's why many tools are available. Okay, AWS is better. Amazon is better. So you can use in this part also. These are the 2 questions. I think it will be clear. IoT monitor wound healing I already discussed. Actually, how IoT can monitor, that is either wound healing or any other sector. Because of that, there is no server concept is there. Purely the infrastructure is. Okay. Or anything else?
So participants, if you have any other questions also, you can write in the chat box, or you can directly unmute yourself and you can ask sir the questions.
It's cloud computing, fog computing, edge computing is better for any kind of IoT based solutions.
I think there is no more questions, I think.
Okay.
So Paramita.
Okay, so thank you, sir. Thank you for your informative presentation. I think that our participants will be largely benefited by the informations you shared in your session. Once again, thank you, sir, for being a resource person in our program. So we are really thankful to you for giving your
Sir,
precious time to us.
Sir, one request, that is, please send the material that I can upload in the Google
Yes, yes, sure, sure.
Drive,
I will
and
share
all
you.
the participants will get there. Okay, sir.
Okay,
Thank
okay.
you.
Today I will share you.
Okay, thank
Okay,
you,
sir.
sir. So now I would like to request our coordinator, ma'am, Mrs. Bapita Roy, to felicitate our honorable speaker with a memento.
Sir, this is the small
Okay, this is
token
very
that
nice.
from our side. Everything is virtual. So please accept
But it
this
looks
one.
nice.
I will send it to your mail.
Okay, okay. Thank you, ma'am.
Okay, thank you, sir, for your informative session. I think
And this is the
participants
good.
also get
So this is the
benefited.
virtual, so that's why this is a physical interaction is not present. But
Yes,
somehow I'm
sir.
very much thankful for inviting me.
Hopefully in future we can meet at our institute, and hopefully I can invite you in our institute in future.
No problem. That is the future first.
Okay,
Stay
sir.
safe in this pandemic situation.
Yes, sir. Yes, sir.
Okay, ma'am. Thank you.
Okay, sir. Stay safe.
Okay,
Okay. Thank you. Okay, participants. So I will end the session and we will meet again 2:30. Today at 2:30, Edgate Technologies will be there for their training session. This is the first session by the Edgate Technologies in this phase. So, and I will share some prerequisite for tomorrow's first half session that will be on the Python programming, and that session will be conducted by the expert from the industry. So there are some prerequisites that you should have with you during that session. I will share the all information that has already been shared by the expert, and I will share those things in the WhatsApp group and as well as in your registered mail ID. So hopefully tomorrow we will be ready with all those prerequisites. Okay. So I'm ending this session and we will meet at 2:30 again. Okay. Thank you.